Hello everybody, welcome back to my video lectures. In this video, I am going to discuss about prediction of range performance. Range means the distance between the target and the radar transmitter. So, prediction of range performance. That means we will be predicting in this lecture. We will be predicting how better the radar can estimate the distance between the target and its location. So, if you see this equation, the maximum radar range in terms of radar and target parameters is R max is equal to PTGAE sigma by 4 pi square S min whole power 1 by 4. This is very standard equation which we have derived in the earlier sections of this unit. Now, for a radar to detect the objects at a maximum distance, all the parameters that are shown in this equation are under the control of the designer, except the cross section of the target. The cross section of the target means at a particular distance. For example, if an aircraft is coming, the size of the aircraft is not under our control, but we can design all the other parameters. We can control all the other parameters. So, for a radar to perform better, the first condition is we have to improve the total power that is transmitted. So, if the total power of the radar is increased, the range will improve. Next, which is normally increasing the power is not suggested. Normally, it is expensive. Next is all the power that is transmitted by the radar should be concentrated in a particular direction. That means the antenna which you are using for the radar transmitter is must be highly directive. So that designing using a highly directive antenna improves the radar range performance. Next is whatever the amount of energy that is incident onto the target will be reflecting back to the radar, and that signal normally will be very weak. We have to collect all the return signal with a antenna of large aperture. That means we have to receive all the echo signal with a large antenna so that the received echo is stronger. If the received echo is stronger, then the detection of the target is easier. So that is the third condition. Now coming to the fourth condition, radar antenna or the radar system must be sensitive to a very least or the very weakest signal also. If all these four conditions are satisfied, then the radar's range performance will be very excellent. Other than these four conditions, there are some other conditions which will prevail the radar range performance are system losses. Generally, we have designed the system. We normally design a system with particular parameters which are not practically the same as we have designed, because the system temperature rises after a particular time of continuous use. Definitely, every system will be heats up. When a system heats up, the reverse saturation currents of all the transistors will vary. Then the design parameters may alter. So these are called as system losses. Systems will not be stable at all the times, so which will affect the performance of the system. So the coming another point is meteorological conditions along the propagation. If the radar is used in a laboratory environment, laboratory condition, then its performance will be very good. Normally, we never use radar in laboratory conditions. We always use the radar in an open atmosphere where many other many clutters, many mountains, buildings, everything will be there. So, which will cause echo signals from so many directions, which will alter the amount of the received signal, because some signal will come in, some signals will come in phase, some signals will come out of phase, which will affect the net output, net voltage that is received by the antenna. So that is called as meteorological conditions. So to achieve good radar range performance, meteorological conditions should be very fine, which is practically may not be possible. Now the third condition and the last condition in this is, which is external to the system, is radar operator. If even the radar is operating well, if the operator is not able to identify the target, then it is a poor performance. Then it reflects on the performance of the system. Then the system is said to be a poor performing system. So these are the parameters that will be prevailing the radar range performance. That is this topic. Let's move on to the next topic, which is called as minimum detectable signal. Consider if your radar is designed for 1 kilometer. If your target is at 500 meters, then it is called as half of the range. If it is at some 800 kilometers, then 800 meters, then it is also called as somewhere around the within the range. If it is, because you have designed your radar for 1 kilometer range, so if the target is at the 1 kilometer point, then you can say, in that condition only you can say R is at its maximum, R max. When R is maximum, the received signal echo from the highest point, the echo which is received from the highest point, highest R max point, is called as the minimum detectable signal, because from that maximum distance the signal which is received will be very weak. Now coming to the definition, this blue line, the weak signal that the receiver can detect is called the minimum detectable signal. If you observe this signal, this is one random signal that is taken to explain this topic. If in this signal, this is the threshold level which will be set by the operator. If the threshold level is set too low, then along with the signal there is a tendency that many noise signals will be appearing above the threshold level, causing a confusion in the operator's mind whether which is the target. So threshold level should not be too low. If the threshold level is too low, then noise may come. If the threshold level were set too low, noise will come. This is called as false alarm. If the threshold level is set too high, this amount of signal strength, the amount of signal that is received depending upon the size of the target. If the target is very large amount of signal will get reflected from the target and the received power will improve. Whenever the received power improved, you should understand that the target cross section is very large. So if you keep too high threshold level, then the signal which is returned from the small targets may not appear. Then this is called as Missive Detection. So it is the decision of the operator who sets the threshold level from time to time, depending upon the meteorological conditions and depending upon the size of the target that he wishes to detect. He should dynamically change the threshold level and have a good detection. So that is called minimum detectable signal. The minimum detectable signal is the weakest signal that can be received from the target, that can be detected by the radar. This for the minimum detectable signal, the operator must set the threshold level dynamically. Okay, I hope you understood this topic. Thank you very much for listening. We'll meet in the coming session.